This section deals with what happens when, instead of just taking a percentage of something, we have an increase or a decrease in the percentage. We're going to use this example to give us an idea of how changing your wording actually has an effect on the numbers you should use. I have a population that increases in size from 200 to 300. I want to find the relative change in the population. Now, hopefully, you will recall that you cannot find the relative change unless you first find the absolute change. So even though it doesn't ask me for it, I need to start out by finding the absolute change. Now the population went from 200 to 300, so it did go up. So I want to arrange my numbers so that I get a positive answer. Oopie doopie. That eraser, I tell you what, is just too much. Arrange so I get a positive answer. 300 minus 200 will equal 100. And to find the relative change then, that means the 200 is my reference value. So I'm going to take my answer and I'm going to divide it by 200. And 100 divided by 200 is 0.5, which is 50%. So when I find the relative change goes along with the words more than. And the sentence, that's 50%, and the sentence that I would write is the new population is 50% more than the original population. The new population is 50% more than the original population. Let's look at it another way. This says write a ratio of the new population to the old population. Now recall, ratio means that we're just going to make a fraction. New population to old population means the new population goes on top. New population was 300. The old population was 200. Now, if I do that on my calculator to reduce it, it's 3 over 2. Now I could change that to a decimal, and that would be 1.5. Now I could also change that to a percentage, which would be, let's move that decimal point over 2 places, and that would be 150%. Oh boy. So let's see how these numbers work into our wording. The new population is how many times the original population. The number we use with times is actually the number that we got for our ratio, but written as a decimal, not the fraction. We would say the new population is 1.5 times the original. Or the new population is 150% of the original. So, okay. What we have is over on the other page, when we use the words more than, that amount was 50%. So the original population is 50% more than the other, but the new population is 150% of the original. Well, the way that that works is this. More than means I am going to ignore how much I started with, and I'm just going to talk about how much I added to get to the end result. Okay? The more than is just talking about the amount that got added. So the amount I started with is 100% of whatever I started with. I added 50% more than what I started with. When I use the word of, I'm talking about how much I ended with. The 100% I started with plus the 50% I got gives me 150%. That's what goes with the word of. So the of is always going to be 100% more than the amount you would use with the words more than, if that makes any sense. But here's how it works in the problems we see. The area of Jose's apartment is 23% more than the area of Alan's. So this is talking about just the amount that got added. If I want to change more than to of, I want to talk about the amount that you have after you added it. So 100% is what you started with, plus the 23% means Jose's apartment is 123% of the area of Alan's. And we didn't talk about this. What if we do less than? Well, if we take less than from the 100% we started with, 100% minus the 25% less than, that would leave us with 75%. A sale price. Do you add 15% to get a sale price, or do you subtract 15% to get a sale price? Well, they kind of baby you here by telling you less than. So you started with 100%. If you're going to pay 15% less, your sale price is 85%. If Carol earns 50% more than William, I want to know how many times larger. Times was that decimal, but it's the decimal that went with the of. So if I want to go 50% more than, this is talking about just the amount of the increase. So we had 100%, we increased it by 50%, so we're up to 150%. That's the word that would go with of. I want to change that to a decimal in order to say the word that goes with times. So 150% is a decimal. Move that decimal point over twice, would be 1.5 times. That leads us right into what I call the two-step problems. The two-step problems are the ones where I was kind of looking ahead for, because this is the idea I was hoping you would figure out on the first day percent problems. We're going to read these problems and we're going to decide whether we have an increase or a decrease. So step one, we're going to decide with our percentage, are we going to add our percentage to 100 or subtract our percentage from 100 based on the fact of, did I have a percentage increase or decrease? Increase is plus, decrease is minus. Now step two is after I do that, I have to decide whether I'm going to multiply or divide by the other number that's given in the problem. And the way I'm going to decide that is based on what the other number is. In the first day I told you, let's examine our numbers and try to figure out, is this a before number where it's like the total amount, the amount that we had before we took a percentage, or is the other number they give us in the problem an after amount, the amount that's like the part of the total, the part after you take the percentage. I purchased a shirt with a pre-tax price of $17 and the local sales tax rate is 5%. What's the final cost? Now I don't want to have to figure out the sales tax and then add it. I want to do this essentially with one calculator stroke. So, start with your percentage because your percentage is step 1. If I have sales tax, does sales tax get added or does it get subtracted? Well, I've never gone to the store and had them subtract sales tax. So, my step 1 is going to take 100% and add my sales tax to it. Now I'm going to have to use this number in step 2. So the last thing I said is you want to make sure you go ahead and change that to a decimal so that sucker's ready to go. Step 2, I have to decide to multiply or divide. The way I decide whether to multiply or divide is to examine this number here. And I have to decide whether that number is the number before I added the sales tax or after I added the sales tax. Well, in this case, it's not that difficult because they told me pre-tax would be before. If the number I have is a before number, I multiply it. So 17 times 1.05 is going to tell me the final price, the after-tax price of the shirt. And that's going to be $17.85. The second example is still talking about sales tax. Again, you look at your percentage first because I have never had anybody subtract sales tax so that the price I paid was less than what it was marked. So yeah, start with your 100%. I'm going to add 7% sales tax is going to give me 107%. I'm going to change that to a decimal so that it's ready for step 2. Step 2, I have to examine the other number that was given. The receipt says I paid that much for my Blu-ray disc, tax included. That means that's the amount that I have after the sales tax was added. After numbers get divided. So I would take 1926 and I'm going to divide it by 1.07 to find out how much that Blu-ray disc was before the tax was added. And that comes out to be $18. I have an item that's on sale for $40 off. Sale should be subtracting, right? So I take my 100% and I subtract 40%, which leaves me with 60%. As a decimal, 0.6. Now, is this $80? Is that before I took 40% off or after I took the 40% off? Well, it says it's an $80 item is on sale, so I'm assuming this $80 is a before. Before numbers get multiplied by our percentage. And that means that $80 item is on sale for $48. Uh-oh. Percentages. Oh, they always mess people up. The smoking rate went up 44% to 10.4%. One of these I'm going to treat just like it's that $80. One of them is going to be my amount of increase or decrease that I'm going to use with my 100% in step 1. So if I start with my 100%, I need to look in the problem and figure out, okay, did I go up or down? Well, it says up 44%. That's my step 1 number. Up means plus. So that's 144%. which as a decimal is 1.44. If it had said that it was down 44%, I would have done 100 minus 44%, then changed it to a decimal. That means in step 2, the other number that I'm concerned about is this 10.4. I still need to figure out, is that 10.4 a before number or an after number? Is 10.4% before I went up 44 more percent, or is it the answer I got after I added 44%? Well, that's where reading comes in. The smoking rate was up 44% to 10.4. If it went up to 10.4, that means the final answer, the after number, was 10.4. I don't have to change that one. Don't move any decimal points for that one. I'm going to treat it just like it's the $80 and leave it alone. But I am going to divide it by 1.44. So 10.4 divided by 1.44 gives me 7.2, sorry, I blanked out for a minute, percent. I don't have to move any decimals or anything. If I leave the 10.4 as a percent, my final answer will automatically already be in a percent.